What is the true nature of the black hole shadow we see in the universe? Is it really the shape of the black hole itself, or is there something more to it? When we look at a black hole, we don't actually see the black hole directly but instead observe a dark circle, often referred to as its shadow. In mainstream physics, this is called the black hole shadow. However, in the energy filament theory, this shadow is not just a simple representation of the outer boundary of the event horizon, but rather it results from light being drawn into a looping orbit around the black hole. The light follows a specific path dictated by the intense curvature of spacetime, creating a standard circle that we perceive as the black hole's shadow. To visualize this, imagine a massive whirlpool. No matter whether you drop a leaf, a foam ball, or a small wooden block into it, all of these objects will eventually be pulled toward the whirlpool's edge, following similar circular paths. Despite their different shapes, these objects are all transformed into the same pattern by the same dynamic forces at play. In a similar manner, the shadow of a black hole comes into existence as the light gets bent by the black hole's extreme spacetime gradient. The closer the light gets to the black hole, the more sharply its path curves, until it reaches the event horizon, where the path of the light is stretched out significantly. It's almost as if the light is trapped in the universe's own death spiral, where it keeps looping around, unable to escape. The trapped light does not fall directly into the black hole's singularity, but instead, it continues to loop in a very narrow region, becoming weaker as it oscillates. To an observer from a distance, this constant looping appears as a dark, the stable boundary, the event horizon, which is where we see the so-called shadow of the black hole. The light around the black hole remains bright, while the trapped light, which cannot escape, eventually converges into a dark circle, giving us the familiar, uniform appearance of a black hole's shadow. The truly fascinating question is, why do all black hole shadows look identical, regardless of the black hole's size, age, or material composition? The answer lies in the concept of critical curvature within the spacetime gradient around the black hole. When the curvature reaches a certain threshold, that of a black hole, the light's critical orbit becomes nearly identical across all black holes, irrespective of their differences. This is much like how the openings of a funnel retains the same shape regardless of the size of the funnel. In other words, the shadow of a black hole is not a unique representation of that specific black hole, but rather the result of the space-time curvature's influence on light. So, the black hole shadow is not simply a selfie of the black hole. Instead, it is the trace left by light as it moves through the extreme curvature of spacetime. The larger the black hole, the stronger the curvature, which means the light's path becomes more predictable, resulting in a more standard shadow that appears the same across different black holes. In the energy filament theory, we explain that black hole shadows are formed by the way light is manipulated by the gravitational and spacetime forces around the black hole. The shadow reflects the destiny of the light, while the event horizon is the true skin of the black hole. The shadow is not just a simple geometric projection, but is the final outcome of the intricate dance between light and the extreme conditions near the black hole. In the next episode, we will explore: why do larger black holes behave strangely? Why do larger black holes appear to be more stable, quieter, and even more mysterious than smaller ones? Tap follow, share it on New Physics, Clear Universe.